Good evening, everyone. Thank you so much, Demi, for the nice introduction. So, my name is Rajitha Navarathna. So, I'm working as a principal data scientist at OCTAVE, where I work in retail, beverages, insurance, and many more business domains. And myself and my team is responsible to create high quality data science projects and solution to solve some of the business problems using data at JKH. So let me introduce my colleagues too. Today with myself, we have Asanga Gunawardena. So he's working as a data scientist at OCTAVE, where he's heavily working in retail. So he has done his bachelor's in University of Monash in Australia. And we also have Dinusha Disanayake. She's working as a data scientist as well at OCTAVE, where she's heavily working in beverages domain, where she is leading a couple of projects in beverages in CCS with John Keys Holdings. So she has done her studies in BSc and MSc in University of Paradise. Okay, so hopefully this is going to be a very interactive session too. And if you have any questions, do shoot us, and hopefully we can help you guys to understand some of the questions and how to solve a data science problem. So as you probably are aware, this particular round, we are heavily targeting how we are going to solve a problem, especially in different areas. So this is like the machine learning roadmap that if you take like a business problem that you want to solve. So this machine learning roadmap consists of 7 steps, and the first step is actually you heavily work with your businesses or to understand the problem. Okay, what is the problem that you are going to solve using machine learning or data science? Right? So if the answer is no for that particular problem, you don't need any machine learning, or you don't need any data science type of analytic solutions. So sometimes there might be some problems that you can only solve this type of problem just talking to some of the customers. You can do like a very simple survey, so you might have the answer. So you don't have to do very fancy ML or AI or this type of work to solve that problem. All these DSS, what data scientists is try to solve a problem using data. So if the answer is yes, you do need to require to look at a couple of more parameters. One is the time. So how much of time you have to solve that particular problem. So sometimes we might have 3 months, sometimes we might have 6 months, sometimes we might have 1 year, sometimes we might have half an hour. So the time is one huge factor. So in this particular competition round, you are pretty much aware that for the first round, we have a time limit of 2 or 3 days. So you have to solve that particular problem within a given time period, right? 11 to 30 days. So yeah, that's the first factor. So the second factor is the resources, whether you have the appropriate resources. So you need to make sure that your infrastructure is ready to go before you start this problem. So if you are working in Python or other, make sure that your platforms are ready before 11th, and double check it with some examples to make sure that your platforms are ready to go. So because that's the second point that will affect to solve this problem. And also it's common when you start to solve like a real world business problem as well. So the third point is the cost, right? So it comes with a cost factor too. So you need to hire expertise, you need to hire data engineers, data scientists, business analytics, delivery leads, and visualization analytics to solve one data science problem, and also the business, right? So data scientist is not the only role that need to solve a proper data science project. So there's a lot of roles involved, and even the QA engineers also we need in data science, not in software engineering, to do the some of the checkings, and also the platform engineers, cloud managers if you are working in the cloud side as well. So you do need to look into these three areas. So your team also make sure that you provide responsibilities for each particular team member in a different areas as well. One can be data scientist, one can be like a business analytics or data translator. So one can be like a visualization. So his part or her part is specifically working with the visualization. So make sure you define all the roles for the given problem. So the problem we have already provided to you, and also once you have the data science problem, you need to convert into a machine learning problem. So you need to understand. So given the problem, what type of work you are going to do. So some of the common technologies, common methods that data scientists are heavily working on, even in the industry, like one is classification, regression type of problems, supervised, unsupervised, reinforcement learning. So these type of methodologies are heavily working on. So you need to understand. So you given the business problem, you want to convert it to a machine learning problem, right? So that particular part is also we have given to you, so you don't have to heavily work on it. But after that, so this discussion is heavily going to talk about how are you going to solve that problem, right? So the first step is pretty much given to you, but we make sure that we have the proper infrastructure to solve this problem. And also the time is, we have 2 days or 3 days. So there's a time gap too. So sometimes you might need to look into some of the trade-offs too while you are working on this problem, right? You're not going to stop it. So you need to take some smart decisions as well. So when you are going to start this problem, so these are some of the steps you need to look at it. So make sure you connect with your team members and properly discuss, and then make sure you align with your role, right? So that's the first step. So you can do it before Thursday. So the second step is in machine learning roadmap, you have to work with the data. So sometimes you need to understand what type of data you want, structured data or unstructured data, where you might have to work with images, audio. Sometimes you might have to work with the text data. These type of problems. So there's a possibility that you might get unstructured data problem too, where you have to work with images, or you might can get a problem with structured data too, where you might have to work with maybe clean data, maybe not. Okay. And that's also consists with data person step and also feature engineering, where you heavily wanted to understand the data. So that's more important stage. So yeah, you have to spend quite a bit of time to understand this data. So if you don't understand this data, that will actually affect your final submissions and also the final reporting as well. So I'll also go through some of the reporting structure I'm looking after. So you need to submit the report. So the feature engineering, data processing is a heavy workload, and make sure you spend quite a bit of time. So it's not about going after one particular factor, which is accuracy or whatever the evaluation metrics that you are going to use. But make sure you spend the heavy time understand the problem. That's the beauty of data science comes from. And you have the model training, where you try to understand whether we can use some of the training data to understand this problem, and you do some of the evaluation, and then based on that you take some decisions. So maybe then based on some of the decisions, you might have to refine the problem as well. Okay, so you might understand, okay, maybe we can refine this problem, or maybe you will understand, okay, we don't have enough number of data points. Maybe you might have to collect some more data, or maybe you might have to understand the features that you are working on is not good enough. So you may have to add some features, or you may have to remove some features. So these kind of decisions we take, and then it's keep iterating, right? And in terms of the decision making, in the question that you are going to solve, there will be a couple of discussion questions as well. So you make sure that you spend quite a bit of time too, especially where you have to answer those sessions in your reporting. Okay, so the OCTAVE team has done quite a bit of work to give you like a real world data science project, right? It's not like a normal Kaggle competition where I just go after like one metric and you're done. So we wanted to make sure that you will have the good amount of opportunity to work with the entire pipeline of data science, at least up to some extent. So so this particular talk question is pretty much going to be around the structured data. So we are heavily going after to see how you can solve the structured data. So this is the outline where we will go through a couple of data preparation where you can get some amount of understanding about how to do those things. So the second part, we will go through a couple of exploratory data analytics, and we will provide you some hints too. So on the way of this presentation, I will point out a couple of guidelines and a couple of hints for you to have it. So that might help you to solve the problem. And also it will help you to go up in this data science career as well. So these are some of the hints that we are providing you. So it will be really beneficial, and make sure you use these techniques. So I will point it out whenever it is necessary. And then we will go through a couple of feature selections and feature engineering. We'll go through data modeling parts, just a little bit, at least touch base the evaluation matrices. We'll go through the evaluation, and at the end we will also talk about a little bit about visualization and documentations, so you can get quite a bit of understanding about the pipeline, right? So this is the outline. Hopefully you have good interactive sessions, and if you do have any questions, just shoot us, or otherwise you can shoot in the chat, or just shoot it to Dean, so she can pass it to us. Okay, so let's move on from here onwards. So my colleagues Asanga and Dinusha will take over, but I will also jump into whenever it's necessary. But if you have any questions, shoot us. Okay, thanks. So pretty much we are going to do like a discussion type of a session rather than doing a presentation. But we will also hint out some of the hints too for you to understand and how to solve data science problem. Okay, Dinusha, you can take off, or you can share it.
Yeah, Rajitha, thanks. So hi all, I'm Dinusha. So as Rajitha mentioned, we will go through like high level overview of the techniques that you will have to know when you face this problem. So if we start with the data preparation stage, so what do we have? So we might have rectangular data, or we might have non-rectangular data that is in JSON format. And if we get from non-rectangular data, you will have to do some steps to get a very structured rectangular data. If we go to the
this is the blueprint number one, where you may have to decide like what type of data you are going to have. I think Asanga, you guys are heavily working on.
Yeah, Rajitha. So hi everyone. Hi everyone. Give me a second. Can you hear me, Rajitha? Or is there like can you hear me, Rajitha?
Yeah, or is there like we can hear you.
There's an echo, Asanga.
There's an echo, Asanga.
So maybe I'll take it. So when you have a structured data, so you can divide it into two parts. One is the rectangular type of data. Yeah, you heavily work with the CSV files, Excel files. Probably in university career, most of the time you will work with structured data. You heavily work with CSV files, or sometimes you work with databases as well.
Hello.
All the data in like a specific structure. Can you hear us, Asanga? In terms of the non-rectangular data, where the data is not pretty much structured. So XML file, JSON files. So these type of dictionary files, like they are pretty much non-structured data. So this is the number one you need to understand. Once you get the data, just look at the data and see like whether you it's a rectangular data or non-rectangular data. If it is not non-rectangular data, you may have to convert into a rectangular data. Okay, so you may have to do some codings.
Hello.
Okay, so that's hope this is pretty clear for you. Hey, Asanga. Can you hear us?
Yeah, I can hear you, Rajit, but I think my voice. I can hear you, Rajit, but I think my voice.
Okay. Until he figure it out his internet problems, let's move on. Dinusha, are you in the call too?
Yeah, I'm here, Rajitha.
Yeah, I'm here.
So let's move on.
Yeah, so the
For data preparation. Anyone has any questions? No, it's okay for you. Okay, let's move on. Dinusha, can you see my screen?
Yes, Rajitha. So, so one of the next steps, which is very important, is the data preparation step. So before we start any analysis, we have to check whether the data is clean. For example, here in this snapshot, but I think Rajitha or Asanga can correct me if I'm wrong, but we have seen, like, for example, in this Latino. So if you look at ethnicity, there's this Latino, Asian American. So there might be cases where you miss one spelling. So when you do something like simple group by, so even if it should come into one group, you might, because of this unclean data, they might go into two groups. So things like that can happen. So you have to correct errors and clean the data before you start your analysis. Rajitha, can you go to the next slide, please?
Yeah, go ahead.
Yeah. So if we look at some, so we are going to give you some data cleaning guidelines and which to look into it, which areas to look into. So if you look at data cleaning, there can be three areas. Like there can be basic data cleaning methods, some outliers, some missing values. So, and to dive deep into basics, there can be redundant samples or redundant features. The data can be duplicated, or like there can be features like, say the primary key is a person. So there can be one feature calling he's a male or not, and another feature calling that person is a female or not. So it's a one column is a redundant feature. And then there can be outliers, outliers which will skew all your results. So outliers mean extreme values, and when you get averages and all, it will change your results. And also there will be missing values where you before you start analyzing it, you have to identify those some values are missing, and if you want, you can impute them. There are like many other ways to handle missing data, so this is just a high level overview.
Domini, maybe if you can just unmute me. Can you hear me?
Yes, Rajat.
Yes. Yes, sir. We can hear you.
Hello.
Yes.
Ah, yeah. So just wanted to point out. So this is the point number 2 for you. So when you start to work on this problem, if you have a data cleaning part, so this particular slide might help you, or guideline might help you to understand where are you need to go after, right? So there are three components. One is basic, outliers, and missing, and then as Dinusha mentioned, so you might have to look into the data and figure it out. Whether we have redundant samples and redundant features, or outliers, or missing values. And also, when you have missing values, what are you going to do? So there are a couple of techniques also you can do. So we will discuss in the later slide. But so make sure you have this snapshot that might help you to understand your data, and definitely this will be a one part that we have to work on. And all the analytics that we are working on in terms of the training, we must document in the documentation. And all these the parts are will carry some marks. That's what we are really looking at, how we are going to solve the problem. It's not about just looking after the modeling, right? So you make sure you spend quite a bit of time in the reporting as well. And I believe there's an extra day for you to just for the reporting. So you can use that day to finalize your document. Okay, let's move on. So there are a couple of things that you need to look after. As Dinusha mentioned, you can look after some of the features, and also you can even look after whether there's any column where you only have one single. For example, if you are working in like let's say you have some student data. Okay, so for some data based on some of the semester results, and there's a column about your country, right? So I assume everyone is from Sri Lanka. So in that particular column, you have only one value. That's basically Sri Lanka, right? So these type of columns might not be useful for your modeling. So you make sure you can remove those columns. So you can spend some time to understand this there. So obviously you must spend quite a bit of time actually understanding these features. I think the second point is you might see some duplicate samples too. So there might be some human errors come to the play, right? So there's a possibility that due to human errors, you might see some duplicate samples in your data. So you need to understand how you can find out. One is you need to find out the duplicate samples. The second one is what are you going to do with the duplicate samples. Okay. So one simple thing is you can just remove one sample, right? Because it's pretty much. And also you can look at some of the features where you have low variance as well, right? So if the variance is pretty low, it's very difficult to find out some useful information. So you can clean those type of features as well. Dinusha, you want to add anything, or Asanga?
Yeah. So to add.
Yeah, go ahead. I think the example that you gave to was interesting too.
Yeah. I hear myself echoing.
Yeah, I think Rajitha, once you speak, if you can mute yourself, otherwise there's an echo.
Okay, thanks.
Yeah, so to add up on what Rajitha said, to like are there features with low variance and all. So when we have a very low variance feature for any model, it will be like very difficult to divide those, like to use that feature to isolate the target variable. And as you know, like there's a term called this curse of dimensionality and all. So if we have so many redundant features, that's not good for the model. So that's why these data cleaning steps are very valuable. I think Rajitha, we can move on to the next slide. Yeah. So, and for the data cleaning, for the exploration part, one very, very valuable tool is just plot some charts and do some explorations. And if you like plot a scatter plot, here you see that ninth value is an outlier. So before you do any analysis, you have to treat these outliers, or else, for example, if we get an average here, it should be around 0 to 0.2. But since because of this 0.8, all our averages will be skewed.
Yeah. Dinusha, sorry, I had issues with my connection. So just to pitch in here, guys, I think the one thing we need to keep in mind when we are dealing with outliers is in certain cases, do we actually need to exclude them? So to give you an example, in retail, sometimes you come across certain items having seasonal sales, and when you look at different outlier removal methods, either through standard deviation or minimum maximum values, maybe you might see that some of these seasonal products will come out as outliers. But in the case of business point of view, it might not make sense to remove these products or remove these sales. So you always have to keep in mind it's important to remove outliers when building your model. But in certain cases, you also have to get the input of the business and understand the data in the specific industry case, and then see whether we should actually remove these outliers. Maybe keeping them would help us to in predictions in certain cases rather than removing them. So you always have to keep that in mind.
Yeah, so here we see like two other examples of visualization. So the second one, if you simply plot a box plot or a scatter plot, we see these outliers and all. So these are two other ways to look into the outliers. And also there can be missing data. And for example, say we are looking at incremental spend or something. And if we are missing the seventh data point, without looking at what's missing, we will just assume the seventh data point is the sixth one, and we will do some incorrect analysis. So it's always good to look at the missing data and then determine whether you want to impute it or whether you want to just remove all the records of missing values. So that's one of the steps that you have to do before you start the analysis.
Yeah, again here, I think so when most of the time when we like participate in competitions, sometimes we don't come across this issue. Like we'll have values for most of the data, but in the real world, relating this to like specific problems that we have resolved in retail, for an example, in certain models to predict forecasts, we've used competitor prices. But we have like so many products, and we've noticed that competitor price has not been captured for most of the products. So in these cases, competitor price can be a very important variable for us to predict our sales. But if we have a lot of missing data, we might not be able to use this as a feature. So again, we in these sort of scenarios, we'll have to take a decision whether to exclude this variable or whether we could go into look into how we could fill these missing data by using different techniques.
Thanks, Sasi. Yes.
Thank you, sir. Let me interrupt you for a minute there. Let me take this chance to remind our team members that you can direct your questions right now during this session, because there will be no separate Q&A session at the end today. So this is your chance to direct the questions. Also, for our panelists, I will, there is a small question in the chat box directed. It is asking that what is the meaning of mark and impute? What does mark and impute mean?
Yeah, hey, then I'll take it. So if you look at the guidelines that we gave it to you, so that in missing component there, so there are two components. One is impute, one is the marking. So the impute means, so if you have a missing components, so you can find some at least approximate numbers based on the data you have, and then you can feed those cells based using that particular data point, right? For example, let's assume that you have 100 data points, and then you have 10 missing values. So you can use 90 data points, and maybe from that 90 data points, you can find the mean, or you can find the median, these type of statistical type of values. So once you calculate these numbers, you can use those numbers and replace the missing values. So then you can assume that the missing cells are behaving similar to mean or median, right? And if you have the mark means, so there might be some cells where you might have 0 values, or you might have some very it's different type of data. For example, you might have a feature where you heavily work with integers, but you might have some cells where you have some categorical type of words, or maybe those type of cells. So you what you do is, so you first identify these type of cells too, and then you just mark it like, okay, you pretty much identify this type of cells, like now where you have issues with the 0 values, or whether you have some categorical things. So then you work with this type of cells where you can remove it, or you can completely remove it, or you can impute the data. So in order to understand whether you want to impute or not, so first you need to identify the sample size of the data, right? So you look at the sample size of the data and see how much of data you have and how much of missing values you have. So for example, let's say you are working on two data sets. So the first data set, you have, let's assume you have 10 data points. Right? So this similar example what Dinusha was talking about in here. So you have 12 data points. So if you have the 12 data points, and you see that there are two points are missing, right? So it's pretty much like 1/6, right? So you're pretty much missing around 16 to 17% of data. And let's say you have a data set B where you have 100,000 data points, and then in that particular data set, let's say you are missing around three samples, right? So this is very, very low probability, right? So if you look at these two data sets, so the first data set, there are two techniques. One is you can completely remove it. In the first data set, it's very difficult for you to remove the samples because you have only 10 or 12 data points. But in the second data set, you have 100,000 data points. So removing around, like 1% is pretty much like negligible. So you can just completely remove it, right? So first you need to look at it, the sample size, and then take a decision. So you always need to have some backups, like why are you doing some interventions, or why are you doing some of these adjustments. So you can look at the data set and then decide. And also there are some applications where you need to decide, like when you impute, what type of impute you need to work on, whether you are going to use mean, or whether you want to go use with median, or whether you want to use the, let's say, the highest number. For example, you can use if you are having like a classes type of feature. For example, like let's say you have a feature with your district, for example. Let's assume that you have a data with some university students recordings, and there's a feature with your district. So if you look at this particular feature, there are only certain number of answers you have, right? So when you have these type of features, you can look into like what type of missing values you have, and then come up with like some of the interesting techniques, like, can we replace with the mean, or can we replace with the maximum, or can we replace with something with median, with median district, for example. So it's always depend on the application as well, but these are some of the techniques you can use.
Yes. Thank you very much, sir, for that explanation. And let me remind the participants once again, our team members, you can unmute yourselves anytime you want, and I'm sorry. So let me remind the team members once again that you can unmute yourselves anytime you want and direct your questions and allay your doubts during this session. So please feel free to unmute yourselves and direct your questions now itself, because we won't be having a separate Q&A session at the end of today. Thank you. And over to you, panelists.
Thanks. So let's move on. So this is the hit number 3 for you. So you can use this particular slide as the third point we wanted to highlight to you. So when you do this data analytics techniques, especially the exploratory data analytics. So if you work on exploratory data analytics, where you try to understand the features, and also you can understand these features in terms of graphically or in terms of non-graphical. So there are 4 components. If you take any DS data science structured data, so this will come under one of these four boxes. So one is you heavily visualization one variable. We call it one univariate. So there's only one feature. So if you wanted to visualize this type of this feature, you can use some of the techniques like histogram, box plot, pie chart. So where we say univariate graphical. Okay, so that's the box. Or you can use some of the non-graphical techniques too, such as mean, standard deviation, coefficient of variation, in order to understand the volatility. So these are like very statistics, right? So if you have like a feature with some numerical values, so you can calculate the mean, standard deviation, these type of things. So where we call them non-graphical, so that's non-graphical. The second one is, so this is the third box. We try to work with more than one feature. Let's say you wanted to understand the variation of 2 variables, where we call the multivariate. And in the multivariate also there are 2 components. One is graphical component and the other one is the non-graphical component. In the graphical component, you can use some of the techniques like scatter plots, correlation matrices, line charts, clustering, this type of visualization techniques. So in your problem that you are going to solve, there are a lot of EDA type of work will need to do before you even start to solve the problem. So you make sure you spend quite a bit of heavy time, especially understanding these features, and also especially understanding some of the correlation of different features too. So as Dinusha mentioned in her previous explanation, she was mentioning about 2 features. Yeah, you might find like higher correlation of different 2 features, and you can use this scatter plot correlation matrices to understand the correlation, and then you can understand how many features you can remove. Because you don't need like a higher correlation variables. Right? So these are, you are only looking at like the linear correlation. Right? Just wanted to highlight these are like a linear correlation. And the fourth component is this multivariant non-graphical techniques, where you look into the chi-squared, ANOVA type of things. So there are, and also the segmentation grouping type of things. For example, let's say you have a data set which we gave you previous example. Yeah, you showed we showed geographical information about, and also some of the demographic information. So you can even use the raw data set and then you can categorize some of the data points. For example, let's say you have age. You have ranging from 18 to 70 or 18 to 80. So you can group it 18 to 25 as a one group, 25 to, let's say, 40 as a second group, 40 to 55 as a group 3. So you 55 plus as a group 4. So you can categorize these things. You can segment. So basically saying grouping. Then within that particular group, you can find some of this non-graphical information like what is the mean, what is the standard deviation, and how many people in that particular category, for example. So these type of stuff. So this will be really beneficial when you do this feature selection and feature engineering. So this, just make sure that you have this slide that will help you to understand where you wanted to visualize, or where the features, and also one feature and also the multiple features as well. So this will definitely be useful. So just wanted to highlight, this might be this is the third tip we wanted to highlight that might help you to solve your problem. Okay. Yeah, Dinusha, you want to take this?
Yes. So guys, the one other thing is feature selection. So as I think most of you know, so if there's correlation for techniques like linear regression and all, this will be a problem. So, and also like when there are so many features, like I said before, there's this very famous quote called curse of dimensionality, where when you have so many features, you can't get all the information out of the features. So it's always better to have uncorrelated features. And as I said, for some techniques like linear regression, it is must to have non-correlated data. Asanga, you want to add it?
Yeah, so here I think, like you said, if you're using generalized linear square models in linear regression, I think you guys all probably know this, that one of the assumptions is that your variables shouldn't have multi-collinearity. So this is something that you could do in your exploratory data analysis by looking at the correlation of different variables. And if you see that certain variables are highly correlated, you could take a call on excluding some of these variables so that you satisfy some of these assumptions in linear, specifically if you're using linear regression. Yeah.
Thanks, Asanga. Before we move to the next session, does anyone has a question or good? Okay, so let's move on. So let's look at a couple of data transformation techniques. So when you say data transformation, so we are initially looking at the data. Okay? So this is the point number 4 for you. So you have a data variable. So let's this is in a structured data. So all these discussions are happening heavily in the structured data, targeting your Kaggle competition. So when you have a data variable, you can have two types of data variable. Okay, one is the numeric. So you have a numeric data. The second one is the categorical variable. So you have a strings. So if you look at the numeric data points, you can even categorize these numeric data points into integers. So you have like 1, 2, 3, 4, or you can have float numbers where you have the decimal points as well. So if you look at the categorical variables, so these categorical variables, you can divide it into 3 parts. One is Boolean, so where you have true, false. And the second one is the nominal type of categorical variables. So the nominal type of categorical variables is, so there's no order. There's no order. For example, like let's say a person's country, Sri Lanka, India, Australia, for example. So if you look at this, the nominal type of categorical variables, so it's very difficult to say Australia is higher than India and India is higher than Sri Lanka. So there's no order. Right? So and the third type of is the ordinal type of categorical variables, like small, medium. So you can see like the medium is bigger than small. Right? So so you have some sense about when you say like this type of categorical variables. So when you look at a particular variable, so each variable will come to one of these boxes. Okay, so you can check it whether it's a numeric or categorical. So that's the first step you want to check it, and then if it is numerical, you have integer or float, and if it is categorical, you'll have a boolean, yes or no, or true or false, and categorical you can have nominal and ordinal. So these are the things which might be useful for you when you want to understand data. Okay, so let's jump in. How do you want to do these transformations? So in terms of the transformations, there are a couple of transformation techniques you can do. One is discretization transformation. For example, you can encode a numerical value as an ordinary variable. For example, if you have the ordinary variables, so you can give like a numerical variable. For example, you can say small is 1, and medium is 2, and large is 3, and this type of things. Right? So you can convert the categorical variables into something meaningful, so something that computer can understand. Right? The second type of things is this ordinal transformation, where you need to encode a categorical variable to numerical. So if you look at some of the features, for example, let's say the country. So still you can give like, Sri Lanka is number 1, and Australia you can give like 2, and India is 3. Right? So, but if you wanted to use these things like training Dataset, so you are saying that the Australia has a higher weight. Okay, so Sri Lanka has a lower weight. So you need to understand how you wanted to transform these type of data when you want to work in, especially in the training set. But let's say assume that that particular feature is your target variable. So then it's okay to give ordinal type of transformation, where you can say like, okay, India is 1, Sri Lanka is 2, and Australia is 3, or something like that. So you are pretty much like a target in that particular feature. So you need to understand before you do any transformation whether this particular feature is going to be in your training set, or whether that's going to be in your testing set as well. Okay, so this is an example. So the most common thing that people are using is the one-for transformation. So encode a categorical variable into a binary variable, right? So for in here, so instead of giving a one number or one categorical variable, you try to understand what type of bins you have. So basically, you try to understand number of classes, and then based on the number of classes, you can provide a vector. So instead of giving a number, for example, such as Sri Lanka, the variable Sri Lanka. So instead of giving a number 1, we can use this variable Sri Lanka and divide it into 3 parts. One is, so this we can have like East Sri Lanka. Second one is East Indian or East Australia. So instead of having the country, I distributed into 3 parts: East Sri Lankan, East Indian, and East Australia. So let's say you are a Sri Lankan. So then it's Sri Lankan, yes, and then for Indian 0 and Australian 0. So then now I'm converting this into a binary form. Okay, so 1 0 0. So it's the same for the other. So just like Indian, East Sri Lankan, that's 0, East Indian, yes, and East Australian, no, that's 0. So if it is like Australian, you can say East Sri Lankan 0, East Indian 0, and East Australian. So you convert these things into a 3 binaries, right? So this,
I think here in some cases it like some of the models that you work with, for an example, if you're using gradient boosting models, you have to do this transformation to your categorical variable. So one-hot encoding is for to run those specific models, you have to convert or do one-hot encoding for your categorical variable. So it also depends on which sort of models you're using. So it's good to keep in mind that these transformations have to be done for certain if you're using different models.
Yeah, exactly. Thanks, Asanga. And also, like you might can see, like in here, like we were using like 3 bits in order to represent these 3 classes. But if you just closely look at it, you can understand you don't need 3 bits. You can represent this all these 3 classes using 2 bits. Okay, so instead of having 3 bits, you can say East Sri Lankan, East Indian. That's pretty much it. So you have East Sri Lankan 10. If it is East Indian 01, and if it is someone else, let's say Australian, that will be 0 and 0. So now you can even remove one entire column too. So this type of techniques you can use it too. So so this is another hint for you guys. So how you want to transform the categorical variables into something meaningful, where you can understand too, and the computer can understand when you work with your model. Okay, let's move on. Asanga, you can take this. Hello, Asanga, you can hear me? Okay, I'll take it. So there are a couple of transformation techniques too. One is normalization transformation. For example, you might, let's say you figure it out the data variable, right? So there is a numerical or categorical, and then you do all these data type of transformation. So let's assume that you did that, right? So you pretty much done. Now you are almost ready to do the model. But now you look at it, the data, and then you find some data points where like some of the variation are in the different ranges. For example, let's say your age might vary from let's say 18 to 25, for example, right? Let's say someone's salary. So the salary might range from let's say 10,000 to like 200,000. So these are in a different scales. So what happened when you use like the raw numbers? So you are pretty much penalizing for some of the variables like age. So you need to make sure that all the transformation are all the variables are in the same range. So one technique that we heavily using called normalization transformation. So where we make sure that the variable is between 0 and 1. Okay. So if you are heavily working on like a regression type of analytics, regression type of problems, so this is something that most of the time you wanted to use. Right? So you can look into the problem that you are going to solve, and then even you can decide what type of techniques you want to use it to. Okay, and the other techniques is use of standardization transformation, where you use the data for a particular feature, and then make sure you transform into where you have another set of data where you have the mean is 0 and the standard deviation 1. So you try to follow like a Gaussian distribution. So these are the two heavy type of transformation. But other than that, there are a couple of more techniques too. So one is the robust transformation, where you look into some of the features where you have the outliers. So this type of transformation are good if you have like outliers. So so they are looking at like so you take the data and then quantile it, and then you look at the quantile Q1, Q2, Q3, and Q4. And the fourth transformation is the power transformation. So these type of transformation are heavily used if your data point, I mean your raw data point, raw data feature is left skew or right skew. Okay? And if you wanted to get like a Gaussian type of a distribution, so you can use this power transformation. So always once you get the data, make sure you visualize it. So we provide you quite a bit of techniques for you to do it, and also look at the data variable. So you look at the data variable, and make sure you do all these data preparations techniques that we discussed, cleaning, missing values, and what is outliers, these type of things, and then you can do some of the visualization. Once you do the visualization, you can understand more information about the data. Right? So these type of the techniques and the visualization, you should include your report too. It takes quite a bit of score as well. Right? So you should spend quite a bit of time in this area as well. Okay. So
Thank you very much, sir. Let me interrupt you once again. Let me remind our participants that this will be the guidance that we offer you all before the first round of the competition. So Masterclass 1.0 will be the guidance we offer you before you actually commence with the competition. So this is your chance to direct your questions and clarify your doubts. So please feel free to unmute yourselves and ask questions from our panelists, or else you can always type it in the chat box so that we can I can direct your questions to the panelists. Thank you very much. Thank you, sir. Over to you.
Thanks. So let us give you another guideline too. So for your project, so this will be very handy too. So this is the tip number 6 for you guys. So let's move on.
Excuse me, sir. There is a question in the chat box. Are there any constraints on software tools that can be used in the competition?
No, but it's totally up to you. So you can use Python or R in terms of programming languages, and you are welcome to use any other platforms like Jupyter or PyCharm. These do the programming as well. So you can pick something that you're very familiar.
Thank you, sir.
Okay. So let me summarize what we were discussed. So so this is the tip number 6 for you to to understand your problem a little bit better. So once you get the data, you look at the data variable and understand whether it's a numeric variable or categorical variable. If it is numerical variable, just look at it whether it's an integer or float. If it is numerical, sorry, categorical, you can even categorize into 3 parts like the Boolean, true or false. So if it's like a true, it will be 1, false, it will be 0. And you can look at it into nominal and the ordinal type of things. So once you understand this, what type of data variable you have, and you can use these type of techniques in order to transform this data so the computer can understand. So if it is like a nominal type of things, one is you can do one-hot encoding, or you can use the dummy encoder where we were discussing about using bits, like for example, here, instead of representing these 3 classes using 3 bits, you can use 2 bits. Okay. And if it is like ordinary type of things, you can use like label encoding. So if you use some of the libraries like scikit-learn, scikit-learn, and even in the PySpark, there are some libraries as well. Even in R also there are some libraries, so you can use those libraries. So you don't have to reinvent the wheel. So just use those libraries in order to convert it. And if it's just like a numeric type of variables, so you can look at it like whether you want to change the scale or not. So if the answer is yes, so you can do like a couple of techniques, what type of normalization techniques you want to use. One is normalization, standardization, robust transformation, power transformation. So you can decide, right? So every link once is represent a question, yes or no. So based on that, you can go to the proper branch. And if it is like let's say you have a numeric and then you want to change the distribution, so you can even look at some of the techniques like power transformation and also like discrete quantile type of things. For example, like age, for example. So age will be like 18 to 70 or 18 to 85, but you can even quantile too. Like 18 to 24 is as group 1, 24 to 40 as group 2, and so on, so on. So, and you might have to do some engineering type of things too. You might have to work with like some polynomial type of transformation. For example, you may find like the row, let's say your feature is x. Now, x might not be good enough. Maybe you might have to work with let's say power 2 or power 3. So you can use like, so you have the x, you can generate another feature column where you can use like x power plus 5, for example. You can do some this type of like transformation as well. So this particular slide, hopefully this will help you to understand where do you want it to go after, just based on the data variable. So this is the tip number 6. Might be very handy for you when you solve the problem. Okay. So let's move on. Dinusha, I want to take this.
Yeah, Raj, thanks. When we look at ML models, there are 3 main types of models. One is supervised learning, unsupervised learning, and reinforcement learning. So if our data set is a labeled data set, for example, for some set of data, the target variable is already defined, then it's a supervised learning data set. We can apply supervised learning techniques for that data set. But if it's like there are lots of features, but there's no target variable, there's no label, then we can go with unsupervised learning. And wherever when we like in real time, we have this real-time feedback from the environment, there we go for the reinforcement learning. For example, for supervised learning, there's this, for example, these decision trees, these linear regression models, those come under supervised learning, and these very famous clustering techniques like k-means, they comes under unsupervised learning. So, and like reinforcement learning mostly used in robot navigations, or like when we use data with sensor data. So those are the main 3 techniques where the machine learning models lie on.
Thanks, Dinusha. And the problem is pretty much is going to be one of those.
Yes.
So the problem is going to be one of these categories, 3 categories. And if it is like a classification, it might be like a supervised learning, so we might provide you the label. So if it is like unsupervised problem, we may not provide you the target variable as well. So if it is like supervised, we have like a classification, and we might have like a regression type of thing. So you are going to solve only one problem, but the problem we might come up from one of these categories. Okay. So let's move on. So we'll give you a couple of more hints too for you. So this is the hint number 7 for your exercise. So once you do all this data preparation, cleaning, and all this data transformation, you understand what type of features you wanted to go after, right? So once you do these features, and then you look at the problem and you understand whether you want to do like a classification problem or regression problem or reinforcement learning problem, or like a clustering problem where you work with the unsupervised type of problems. So once you understand, you work on the modeling, right? So some of these models like linear regression, as Dinusha mentioned, logistic regression, some of the boosting models, so you can use. So you can use some of the existing toolkits, libraries to handle this type of modeling parts as well, in order to solve that problem. So once you have the data, so you might get training data, and you might get a testing data as well. And there's a validation data set too. So entire data set can be divided into 3 parts. One is training data, one is validation data, and the third one is the testing data. So the testing data, you never touch it. Okay? You never touch the testing data until you until you're ready with the model, and then you're about to submit your final report, you just check it. So what you heavily work with training data and the validation data set. So you take the training data to train the model, and you look at the accuracy or the whatever the evaluation matrices that you are going to use between the training data set and the validation data set. So you try to maximize the, let's say, the validation accuracy, and also make sure that you are not overfitting the models as well. Right? So yeah. And you can use some of these hyperparameter tuning. So you pretty much doing the hyperparameter tunings based on the validation test accuracy or the metric that you are going to use. Okay, so you normally don't touch it, the test data, until you about to submit. You use with the training data and you use the validation tip, and you work on it. And there are two main bottlenecks might come. One is your model might be overfitted. The second part is your model might be underfitted. So these are the two things you can get. So you need to find a sweet point where your model might be good enough to test your testing data. Okay, so these are the two things that you need to look after when you do the model training. Okay? So hope it's a little bit clear, like what type of data that you are going to get and how you want to do the modeling. And also we will provide you a data dictionary as well. So once you get the data dictionary, make sure you look at the data dictionary and understand. So the data dictionary give you quite a bit of information for you to understand different variables as well. So it might have like good amount of information about like what is this variable is, like maybe sometimes we might also like provide, okay, use this particular variable as integer 1 or this variable as integer 2. Especially some of the target variables, there's a possibility that information is given for you. Okay, so just to be in a consistent with everyone, so that information might be given to you. So once you get the problem, so go through it and also go through the data dictionary as well. Okay, so this the tip number 7 I want to give it to you. I think there are some issues with let me show it to you from here. So hopefully you can see my screen. So evaluation matrices, you can divide it into two parts. One is the classification modes. The second one is the regression models. So in the classification models, you can have another two parts. One is you have the class labels. So if you have a class labels, there are two other branches as well. The class labels might be balanced data set, so it's a balance. So let's say you have like a classification problem, you want to classify. Let's say someone is going to churn or not in a churn type of a problem. So you have like two classes, and if it is like a balanced data set, means like you have like 50-50 type of, at least approximately 50-50. So if it is like a balanced data set, you can use accuracy, confusion matrix. And if it is like an imbalanced data set, you can use confusion matrices, precision recalls, and also macro advanced score. So this type of matrices you can use. So if it is the imbalanced data set, going after accuracy might not be the correct way of doing it. Okay? So because you might get like high accuracy, but the class sign pretty much imbalanced. Like let's assume that we have example with two classes where one class has 90 samples and the other one is 10 samples. So without doing any machine learning models, I can get 90% accuracy. If I just say all the let's say the testing samples are like 1. So let's assume that you have 100 testing samples as well, and then all the testing samples can get 1. So I can get up to at least minimum of 90%. So going after accuracy might mislead you. Okay, so once you get the data, look at the class variable and look at the distribution as well. So then you can figure it out like where it is. And also if it is like a probability type of things, you can use like confusion matrix, ROC, matrix. And if the problem is going after like a regression type of models, we can use Sorry, this is swap. So if it is like a regression type of models, you can go after the RMSE, MSE, MSE, these type of things. This is actually will cover like most of the things in your modeling part. And there are two more sections we wanted to cover too. So one is the data visualization. Asanga, you can just highlight a couple of things.
Yes. Excuse me, sir. There is a small question in the chat box again. There are two questions actually. The first one is, what are some useful tests to determine if a power transformation would be useful? And if so, what power to use?
Let me take that. If you're working on a power transformation, can you hear me?
Yes.
Yeah. So one is make sure you visualize the data. You visualize the data and understand the skew parameters. What type of skew you have, left skew, right skew. Then you can understand the skewness. So look at the skewness of that particular feature. And then once you identify this skewness, you can start with like a simple transformation, like start with power two. Just start with a simple transformation, and then and also if you have like a single type of variable, you can just visualize this, and then you might can see like some of the variables might have like X squared type of visualization. So then you can just, in that sense, you can say, okay, this is like power two.
Yeah, Rajitha, I think, yeah, to answer that question, like you said, it's one way is you could visualize it and look at your how your variable is distributed. To give you an example, I think in retail we've done transformations to like to the price variable. So we've looked at maybe over time as price decreases, your quantity demanded would decrease. So you visualize this data, and then you sort of identify which power transformation or which specific power you need to use to best mimic this the pattern of the data.
Thanks, Asang.
Yeah.
Thank you, sir. And also, are you done answering the questions?
Yeah, go ahead, yes.
Okay. The next question from Diniti is, sir, when we have imbalanced data set, is it good to balance data set using some techniques before model building?
Yeah, Asanga, yeah.
Yeah, you could use like oversampling, undersampling methods to balance the data, but my personal view is I'm not a fan of using these techniques to sort of balance your target variables, rather because this would mean that you're sort of artificially treating these imbalanced nature of the data. So in this cases, what we would we rarely use in some of the use cases we work, we rarely mostly come across imbalanced data, but we rarely use these methods to balance it. What we try to do is mostly have focus more on the feature engineering part, where we could find specific features to handle this imbalance, like better predict and deal with this situation, rather than like changing your the distribution or like how your data is sampled.
Thanks, Asang. Just a couple of things to add it to. So if you are working in like imbalanced data set, the evaluation matrices that I showed you is different too. Okay, so you cannot go after like some of the matrices like accuracy. You are giving like a wrong information. So you can look at these evaluation matrices as well. Reporting the results to which type of evaluation matrices you want to use. So that's one thing. And if you are working in a like unstructured data, where you work with like images and videos, for example, there are some techniques called data augmentation. So you can use some of these data augmentation techniques as well. You can use some of this rotation. You can crop images. You can flip images in order to get more samples as well. So you can do like data augmentation type of things. If you're working like a structured data, especially in images, many scientists do these type of techniques as well.
Yes, thank you very much, sir. Another question directed to us is, how do we test unsupervised learning results?
Yeah, so if you are, let's say you are working with like a training customer type of like unsupervised, you don't have you don't have like a target variable where you cannot like understand whether this particular solution is good enough or not. But when you solve this problem, there are few variables you can look at it whether you are solving the problem in the right direction. One is people are looking at least this the elbow type of visualization, where you work with different clustering key parameters and see whether you can minimize the interclass difference. Okay, and based on that you can figure it out this particular cluster is good enough for it. And also there are some other parameters like DB kind of parameters as well on top of my mind, and seal-out score. So you can look at those seal-out score as well. In scikit-learn also there are some functions to get those scores. So you can look at those scores as well. So that score is, I think it's vary from -1 to +1. So if it is like closer to +1 means like it's pretty much a good type of clustering, where you can get some sort of understanding about your clustering methods. So,
Yeah,
you can look after it.
yeah, Rajitha, I think some of these methods, like even like the silhouette score, where you try to identify the best cluster split, or like the best number of clusters that you could have in your data, specifically like looking at this elbow method and seeing that this would be the having like say 4 or 5 clusters would mean that my between these clusters it's highly differentiated. So there is, I don't think, I'm not too sure that there is exactly a test to say to look at the accuracy, but you could use these methods to see what the most optimum number of clusters that you could use. So this would give an idea of that it's in terms of grouping this data that you're seeing significant differentiation between groups, and in these groups that you, whatever the variables you have are similarly distributed. So yeah.
Thanks.
Thank you very much, sir. So this is a reminder once again for all our participants. Since we have limited time available, please direct your questions now if you have any. Thank you, sir. Over to you.
So let's go to a couple of more sections. One is the data visualization. So you do all this, machine learning project, data project. So you wanted to visualize this, the final findings. Ask Asanga to give some information about visualization as well. This is just an example. So,
Yeah, Rajit. Yeah, I think this is another key step in our whole use case process, where we have done our exploratory analysis, and we started with data cleaning, obviously, and moved on to EDA, and then we do our model building, and then we do our model evaluation, and then we sort of, based on our results, we reiterate, go through the process again of doing, looking at different features, creating more features to improve our accuracy. So eventually, what we have to, as a business, what we want is like how we can look at these insights, or whatever the model gives out. How do we effectively visualize this so that business could take data-driven decisions? So this is where the like dashboard creation come into place, where we have our model results, and then maybe we can have some of our exploratory data analysis, and create visuals, or create dashboards where the business could look at these dashboards and take decisions accordingly. So one key thing to note down here is that whatever visuals you populate in a dashboard, it should answer like a couple of key questions, like is this visual helpful for the business to take any decision, or is it an actionable visualization? We could add, based on like whatever visuals are there in a dashboard, we could add hundreds of ways of displaying these visuals. But end of the day, what you need to realize is, am I making sense in terms of for the business to take actionable decisions? So that's why we need to look at, when you're creating dashboards, you need to initially come up with a wireframe and try to validate it with business. So like that, in your case also, when you create these visuals, you need to make sure that whatever you're trying to show, it makes sense.
Yeah, thanks,
Yeah.
Asanga. So in this particular problem, you are not only going to solve like a Kaggle competition as we mentioned in the beginning. So you are also going to get 50 points for the reporting as well. So this is another area you need to work on. So once you do the developing, there's a discussion part as well. Yeah, you need to work on, which can help you to develop this type of plottings. So you can use some of the tools like Matplotlib if you're working in Python. R also have some things. If you're working in MATLAB, you can use MATLAB plots, or you can even like use some of the simulations as well. In Microsoft, you can use the Power BI dashboards if you are familiar with it too. So you also need to think about it once you start to solve the problem, how you are going to visualize this. So this will be quite handy. So we will also like look into that part too. You will get some points, and also some of the bonus points as well. Okay, let's move on to the last ones. Especially wanted to give you a couple of hints about the documentation as well. So just follow a similar type of structure where you can discuss about the problem context, make sure you understand the problem, aims and objectives, and section B, C, and D are heavy sections where you need to spend understanding about the data processing techniques. So you make sure all the techniques that you are using in your project is documented. And make sure you do visualization too, and also use some of the blueprints that we gave it to you, and make sure that follow those paths that might help you to land with the proper techniques as well, and also the exploratory data analytics. And also when you work with the model features, you can write about the features and also some of the feature engineering stuff. So maybe some of the features might not, might not given to you. So you may have to find those features by yourself using maybe couple of features, or maybe using you can into a different transformation. So you may need to do some feature engineering as well. So all the feature engineering techniques that you do, you need to write in the document as well. And also the model methodology, what type of methodology you are going to use, and in terms of evaluation, what type of matrices you used for the evaluation. And also if you are working like a classification type of things, you can represent the results in terms of the confusion matrices, and also the guideline that we gave it to you. Use that guideline in order to do some of the visualization. And once you come to do visualization, make sure you spend some time for the discussion section as well. You may have to answer three questions that might help you to understand the entire problem, and also do some final visualization too, as Asanga mentioned. So that might cover you the entire document as well. So you have extra day too. So you make sure you spend quite a bit of time too, because this particular report takes 50 points. It's about half of your overall score as well. Okay, that's pretty much it. That's the
Rajitha, I think there's another question. Whether you could use Power BI for visualization. Yeah, definitely you could use Power BI. In most of our work at Octave, we use Power BI for dashboarding. Yeah, this is definitely a tool that you could use for this.
Yeah, definitely. If you are familiar with Power BI, please use that. Make sure you put screenshots as well in your document. Okay, and also make sure you describe what it is in that particular dashboard too. Like otherwise, it's very difficult for us to understand what is it. So you make sure you spend some time on discussion stage too. Okay, that's pretty much it. So hope that clear you quite a bit of information too, and we also gave some hints for you to solve this problem. And so once you get the question, you make sure that you connect with your team members and make sure you understand what is the role that your team members are going to play. Okay, so make sure that it's clear with everyone, and then you started to work on the problem. Okay, and hopefully these sessions might help you to solve this problem in a nice way. And also spend some time for the documentation. That's also very important as well. And I think the competition people, they have given you a one more study as well. Okay, that's pretty much it then.
Rajitha, I think we have one more question.
There's another one more question. Do we have to attach code as appendix to the report?
Yeah, you can do.
Okay. So I think all the questions are being answered. So
I think the question will release on Navanta, I guess. You can check with that. You wanted to highlight anything here?
Sorry, Rajitha.
I was not Asanga. The analysis, I don't know. Dikshan is here. Do you have any?
Is there a page limit for the report? Rajitha, is there a page limit for the report? I don't.
There's no page limit.
Yeah.
What I want heavily is you make sure that you cover these things. Okay. So once you do this exercise will give you quite a bit of information how to solve this problem. I just wanted to highlight the couple of matrices that you can use for the k-mean clustering. So one is the silhouette score, and also there are a couple of more matrices as well. One called Davis Boolean score. So just Google it. The abbreviation is DB. DB is Boundary Scope. That's a mathematical equation for that. And also there's one more metric called that's the abbreviation. The name is Balansky Habermas. That's the other metric. So you need to look at all these three matrices in order to understand whether the decided K is good enough or the decided K is the correct. So basically, looking at the intra-class variation, also inter-class variations. But for this particular report, elbow method is good enough. Okay, I think that's pretty much it from our end.
Yes, thank you so much. So with that, I think we have reached the end of today's session. And let me grab this opportunity to thank the professionals, Dr. Rajitha Navarathna, Mr. Asanga Gunawardena, and Ms. Dinusha Disanayake, who joined hands with us today amidst their busy schedule. Thank you very much for an informative session, which I think covered everything that our team members needed to clarify before the competition. It was a great honor and a pleasure to have you with us here today. Thank you so much.